What is heat?
Energy transfer that results from a difference in temperature is called heat. Heat always flows from the hotter, energy source, to the cooler object, energy receiver. Heat is transferred by conduction, convection, and radiation.
What is the conservation of mass?
Mass is neither created nor destroyed in chemical reactions.
What is air drag?
Friction caused by an object moving through air. Drag depends on velocity, area, shape, and the density of the air.
What are difference tones?
Difference tones are frequencies that are produced as a result of two different frequencies mixing with each other. This mixing can only occur if a device is nonlinear. That is, if the output is not a multiple of the input. You can create difference tones with two toy slide whistles. Place both in your mouth and blow hard. Adjust their length so that the two tones are the same pitch. Then adjust one. As you move its pitch away from the other, you will hear a low-pitched sound whose pitch increases as the two whistles' pitches get further apart. For example, if the high-frequency sound was 812 Hz, while the lower frequency was 756 Hz. The difference tone from the interfering sound waves would be 144 Hz. The nonlinear device in this case is your ear.
What is an arrow of time?
The forward direction of time is the one in which entropy increases or remains the same.
What is a lunar eclipse?
A lunar eclipse occurs when Earth is directly between the Sun and the Moon. Earth blocks the Sun's light rays from hitting the Moon, leaving it in complete darkness. For an observer on Earth, a shadow appears on the Moon, causing it to become dark. As Earth moves out from between the Sun and the Moon, the Moon is gradually illuminated until the entire full moon is seen again.
What is physics?
The study of the structure of the natural world that seeks to explain natural phenomena in terms of a comprehensive theoretical structure in mathematical form, from the Greek physis, meaning nature.
What is used to reduce red eye?
Red eye reduction is a feature found on many modern cameras. It simply attempts to constrict a person's pupil so that not as much light can be reflected back from the retina. There are several methods of accomplishing this. One method is to have a smaller light that illuminates before the real flash. Another method is to have a quick burst of 5 or 6 mini flashes that cause the pupil to contract before the picture is taken.
How is atmospheric pressure measured?
A device to measure gas pressure is called a barometer. There are two major types of barometers, the mercury barometer and the aneroid barometer. Galileo's secretary, Evangelista Torricelli, 1606 to 1647, the unit of pressure. The Tor, was named after him, developed the mercury barometer in 1643. It consists of a thin glass tube about 80 centimeters, 31 inches, long, which is closed at the top. Filled with liquid mercury and placed upside down in another mercury-filled dish. Depending upon the atmospheric pressure pushing on the mercury in the dish, the level of mercury in the tube will rise or fall because there is no air above it. By measuring the height of the mercury, which would usually be between 737 and 775 millimeters, 29 to 30.5 inches, high, atmospheric pressure of the atmosphere can be measured. The most common household barometer is the aneroid barometer, in which atmospheric pressure bends the elastic top of an extremely low-pressure drum. By measuring the amount the top bends, a measurement of atmospheric pressure can be determined. The aneroid barometer is often used in airplane altimeters to measure altitude. Since atmospheric pressure decreases as altitude increases, the aneroid barometer is an ideal instrument to use. It is much safer than the mercury barometer, because mercury vapor is poisonous and the mercury must be exposed to the atmosphere.
How can these two quantities be equal?
The answer can be found by looking at Newton's second law again. In the form F net equals ma, you can see that the units of force, newtons, must be equal to the units in which m times a are measured. The mass, m, is measured in kilograms and the acceleration in meters per second squared. Therefore a newton must be a kilogram times a meter per second squared. Thus a newton per kilogram, n/kg, is a meter per second squared, m/s2.
What is speed?
If something moves from position to position, then speed is a measure of how fast it moved. Speed is defined as the distance moved divided by the time needed to move. Both change in position or distance and time are measured quantities. Frequently, speed is called the time rate of change of distance. For example, if you drive 240 miles in 4 hours, then your speed is 60 miles per hour, abbreviated mph. It is unlikely that you drove the whole trip at a constant 60 miles per hour. This example calculated your average speed. If you were pulled over for speeding and were told you were going 80 miles per hour, you wouldn't be able to avoid a ticket by saying, "But officer, my average speed is only 60. The vertical lines you see on a map or globe are lines of longitude and the horizontal lines are lines of latitude.
Who is considered one of the most influential scientists of all time?
Many scientists and historians consider Isaac Newton (1643 to 1727) one of the most influential people of all time. It was Newton who discovered the laws of motion and universal gravitation, made huge breakthroughs in light and optics, built the first reflecting telescope, and developed calculus. His discoveries, published in Philosophic Naturalis Principia Mathematica, or the Principia, and in optics are unparalleled and formed the basis for mechanics and optics. Both these books were written in Latin and published only when friends demanded that he publish. Many years after Newton had completed his work,
What is the source of every sound?
sound waves are created by some type of mechanical vibration or oscillation that forces the surrounding medium to vibrate. A tuning fork is an excellent example of a vibrating sound source. When struck by a rubber mallet, the tines of the tuning fork vibrate, causing the air molecules around them to move back and forth at the same frequency, creating areas of compressions. Where the molecules are close together and air pressure is slightly increased. And rarefactions, where the molecules are spread apart and thus the air pressure is reduced. These pressure changes then move away from the tines, creating the longitudinal sound wave.
What supplies this centripetal force?
Centripetal force must be supplied by something or someone exerting the force on the object. In a rotating drum ride at a carnival, you stand with your back on the drum. As the drum speeds up, you can feel the force of the drum pushing on your back toward the center of the circle. Often the floor drops down and only the force of friction between your back and the drum keeps you from dropping down with the floor.
What is the tallest building in the world?
The tallest building, until recently, was the Sears Tower, now the Willis Tower. In Chicago, Illinois, which was built in 1974 and is 443 meters, 1,453 feet, high. 3 new skyscrapers in Asia now surpass this height. The Petronas Towers in Malaysia, completed in 1996, are 452 meters, 1,483 feet, high. The Shanghai World Finance Center in China, completed in 2008, stands 492 meters. 1,614 feet, high, almost half a kilometer into the sky. The Burj Dubai, Dubai Tower, 818 meters, 2,684 feet, high, the world's highest, opened in January 2010.
What methods are being used to reduce noise pollution?
Since noise creates stress and can lead to other health problems. Industries and governments around the world are working to reduce noise levels, especially around populated regions. One method of reducing noise pollution around airports has been rerouting airline traffic so that it passes over less populated areas. Sound barriers have been installed along many highways to absorb and slash or reflect sound away from houses built alongside the roads. In countries such as Austria and Belgium, roadways are being constructed with a material called whisper concrete that engineers claim reduces noise by 5 decibels. Finally, Swedish engineers have developed a road surface made of pulverized rubber that can reduce the noise level by as much as 10 decibels.
What is reverberation time?
The reverberation time for a sound is the time it takes for the echoing sound to diminish by a factor of 60 decibels, that is, to 1/1,000,000,000 of its original intensity. The longer the reverberation time, the more echoing is heard because the sound has reflected off walls and other surfaces. The shorter the reverberation time, the less echo is heard.
What are other contact forces?
You might think of rubber bands on slingshots, roads on the wheels of your car, or ropes pulling carts. Water and air can also exert a force. Think of a stick moving down a stream. Or what you feel when you stick your hand out the window of a fast-moving car.
How was nuclear fission discovered?
Italian physicist Enrico Fermi, 1901 to 1954. Was appointed professor at the University of Rome at the age of 24. Among many projects in which he and his group were involved, perhaps none was more important than his studies of the reactions produced when slow neutrons struck nuclei. Fermi had discovered in 1934 that slowing neutrons by passing them through paraffin greatly increased this ability to produce nuclear reactions. He did systematic studies of the results of bombarding a series of materials with slow neutrons. The German chemist Otto Hahn, 1879 to 1968, had a distinguished career that included inventing the field of radiochemistry in 1905. Using chemical techniques and measurements of half-lives to study the results of nuclear reactions, he had discovered dozens of isotopes and at least one element. 3 times he was nominated for the Nobel Prize. Since 1907 he had collaborated with the Austrian physicist Lise Meitner, 1878 to 1968. The teamwork between a physicist and a chemist was a great advantage. Hahn and Meitner, together with Hahn's young assistant Fritz Strassmann, 1902 to 1980, employed Fermi's slow neutron techniques to create nuclear reactions, and thus more isotopes. When, in 1938, they tried bombarding uranium with neutrons, they expected to create new elements beyond uranium in the periodic table. But they kept finding the element barium in the bombarded uranium. Starting in 1933, the Nazi regime forced people of Jewish origin out of all laboratories and universities. Meitner, who had Jewish parents but had converted to Protestantism in 1908, was protected because she was Austrian. But, when Austria was incorporated into Germany, she lost that protection. In July 1938, she took the train from Berlin to the Netherlands. Thanks to the intervention of 2 Dutch physicists, she was allowed to leave Germany, but with no possessions. She soon moved to Sweden and kept up her collaboration with Hahn by mail. On December 17, 1938, Hahn and Strassmann submitted their findings for publication but admitted that they had no explanation for the appearance of barium. Meitner and her nephew Otto Frisch utilized Niels Bohr's liquid drop model of the nucleus and Einstein's E equals mc2 equation to propose that the nucleus had split into 2, releasing both extra neutrons and a large amount of energy. The Meitner-Frisch paper was submitted a few days after Hahn's. Frisch returned to his laboratory in England and confirmed Hahn's result in January 1939. Hahn won the Nobel Prize in Chemistry for his work in 1944, but Meitner never did. It was not long after scientists figured out how to create nuclear fusion that the Nazis began conducting research on how to turn this science into a powerful bomb. Albert Einstein and physicist Leo Szilard urged U.S. President Franklin D. Roosevelt start a program to complete a nuclear warhead before the Germans did.
Why are water towers needed on tall buildings?
A typical home requires water pressures of 50 to 100 psi. City. Water systems use pumps to maintain that pressure in the pipes. Vertical pipes are needed to supply the upper floors with water. Each foot of height reduces the pressure by 0.443 psi. Auxiliary pumps at various floors can provide the needed increase in pressure. An alternative is to put a large storage tank on the roof and use pumps to fill it. It then supplies the building with water under pressure due to the height of the tank. It also allows the pumps to be run to fill it at night when electricity rates may be cheaper. In addition, it provides a backup source of water in case of fire. Small towns, which often use wells as a water source, use water towers to store water in case there is an interruption in electrical service. It also allows the town to use smaller pumps because the tower can supply the pressure during peak water demands. A typical daily water use is 500 gallons per minute. But this can rise to 2,000 gallons a minute in peak times. A tower typically stores 1 day's worth of water. Water towers such as these in New York City are often placed on top of tall buildings. This way, the force of gravity supplies the water pressure needed to deliver water throughout the building.
What is momentum?
The product of mass and velocity P equals mv, vector.
What are microwaves?
Electromagnetic waves with frequencies above about 3 GHz.
On what does the amplitude of a wave depend?
The amplitude of a rope wave depends on how hard you shake it. For a sound wave, it depends on how much compression the loudspeaker or musical instrument creates. In other words, it depends on the energy the source put into the wave. It does not depend on frequency, wavelength, or velocity.
How does light become polarized?
Light can be polarized in 2 ways. If a shiny surface such as water or an automobile window reflects light, it can be partially polarized. Or, you can use a polarizing filter that passes only the light that has the electric field in one orientation. A Polaroid filter has long, thin molecules, all oriented in the same direction, embedded in plastic. The molecules absorb light that has an electric field parallel to the long dimension of the molecules. Therefore, the light passing through the Polaroid has an electric field perpendicular to the long dimension of the molecules.
When was the first atomic device exploded?
The gadget was a test version of the plutonium bomb. It was installed on the top of a 30-meter, 100-foot tower in the New Mexico desert at a location 35 miles southeast of Socorro, New Mexico, on the White Sands Proving Ground. The explosion, called Trinity, occurred on July 16, 1945. The energy yield was about 20,000 tons of TNT. More than twice what had been expected. The implosion-type bomb was much safer and more effective than the cannon-style Little Boy design and has been used for all other nuclear weapons.
Who developed the Celsius scale?
On the Celsius scale, the freezing point of water is 0 degrees and the boiling point is 100 degrees. The Celsius scale is named after a person whose life work was dedicated to astronomy. Anders Celsius, 1701 to 1744, a Swedish astronomer, spent most of his life studying the heavens. Before developing the Celsius temperature scale in 1742, he published a book in 1733 documenting the details of hundreds of observations he had made of the aurora borealis, or northern lights. Celsius died in 1744 at the age of 43.
What is nuclear fusion?
Nuclear fusion is the opposite of fission. Two nuclei join, or fuse together, forming a more massive nucleus. The mass of the resultant nucleus is less than that of the reacting nuclei, so energy is released. Because the reacting nuclei are both positively charged, there is a large repulsive force between them. To overcome this force, the reacting nuclei must have very high energy. Fusion was first observed by the British physicist Mark Oliphant. 1901 to 2000, in 1932. A typical fusion reaction involves two isotopes of hydrogen, 2H, or deuterium, and 3H, or tritium. They fuse to produce 4He, releasing a neutron. The energy released is more than 1,000,000 times larger than that released. When an electron combines with a proton to produce a hydrogen atom, nuclear fusion occurs naturally in stars like our Sun, but reproducing a fusion reaction in the laboratory has proven to be very difficult because it takes a lot of energy to fuse nuclei together.
What is a transverse wave?
Wave and its energy move perpendicular to the direction of oscillations.
What is a coulomb?
Equal to the charge of 6.24 x 1018 electrons, negative, or protons, positive.
Why are broadcast frequencies so limited?
Suppose the analog signal is a 440 Hz tone, the A above middle C on a piano. A typical AM transmitter would have a carrier wave frequency of 1 MHz. The result is a signal with three different frequencies, 1 MHz, 1 MHz plus 440 Hz and 1 MHz, 440 Hz. Thus the total signal requires a set of frequencies 880 Hz wide. Sounds with a frequency of 4 kHz require a range of frequencies called the bandwidth, 8 kHz wide, just about the spacing between adjacent stations. FM stations, on the other hand, were developed to transmit sounds more faithfully. Which means that sounds up to 15 kHz must be accommodated. That means that the bandwidth of the broadcasts is 30 kHz wide. At the very high frequencies used by FM stations there is more bandwidth available and stations are spaced by 200 kHz. The electromagnetic spectrum has many other users. Police and firefighters usually use AM while aircraft, where noise reduction is important, use FM. Television stations used to use AM for the picture and FM for the sound. But as of June 12, 2009, they now all use digital signals. Other users are the military, marine ship-to-shore services, weather broadcasts, commercial mobile phones, the citizen band, and amateur radio operators. They all share the HF, VHF, UHF, and SHF bands.
What energy transfers are involved when a ball is tossed?
If you lift an object like a ball, you increase the energy in Earth's gravitational field. Energy is transferred from you to the field, resulting in a decrease in your stored chemical energy. CP 62. Suppose you toss the ball up. When you toss it, you do work on the ball, transferring energy from your body to the ball, increasing its kinetic energy as well as the gravitational field energy. Once you let go of the ball, it continues to rise, but its velocity decreases as the gravitational field energy increases and the ball's kinetic energy decreases. It reaches its maximum height. At that instant the kinetic energy is zero, all energy is in the field. On its way back down it speeds up. So its kinetic energy increases but the energy stored in the gravitational field decreases. While you are not touching it, the sum of the kinetic energy of the ball and the gravitational field acting on it is a constant. Energy changes from one form to the other and back again. As you catch it, stopping its motion and thus reducing its kinetic energy to 0. The ball does work on you, but your stored chemical energy does not increase. When a moving pool ball collides with another one, All or part of its kinetic energy will be transferred to that ball, which is what makes this fun game possible.
What is a refractor telescope?
The refractor telescope was the first telescope ever created. It employs one lens to gather, refract, and focus light toward an eyepiece. The eyepiece contains one or more lenses that create an image that the eye can see.
What is the nuclear model?
Extremely small positively charged particle, the nucleus, surrounded by electrons.
What is optics?
Optics is an area of study within physics that deals with the properties of and applications of light. Optics can be used not only with light, but with other parts of the electromagnetic spectrum, including microwaves, infrared, visible, ultraviolet, and X-rays.
Are other muscles and bones in your body so easily characterized?
Most are not because tendons that transmit the force from the muscle to the bone are long and go through several bends. Consider sports equipment like baseball bats, tennis rackets, and golf clubs. They are often used as extensions of your arms. So the person plus the bat or club has to be examined together. But note that in every case the SYSTEM is a third-class lever, where a large distance moved, and therefore greater speed, is favored over an increased force.
What is the elastic collision?
In a collision, the kinetic energy of colliding objects is the same before and after the collision.
What is a simple machine?
Device that matches human capabilities to do work to tasks that need to be done. There are four major groups: the lever, the wheel and axle, the pulley, and the inclined plane.
What is tension force?
Force that pulls an object apart. See tensile strength.
What is the interference of light?
We've explored wave interference before in the waves chapter. The key to the interference of light is that the two or more, waves interfering must have the same wavelength and phase. While interference can be seen with ordinary light, interference is most easily seen using laser light. If light from a laser passes through two slits that are a small distance apart, the diffraction patterns from the two slits will overlap. When they do, a pattern of light and dark bands will be seen. The bright bands are where waves from the two slits are constructively interfering. The distance the light has traveled from the two slits will be equal, or they will differ by an integer number of wavelengths. The dark bands occur when the waves destructively interfere. In this case, the difference in distance light from the two slits will have traveled will be an odd number of half wavelengths. That is, 1/2, 3/2, 5/2, etc. Light can also interfere if it is reflected off two closely spaced interfaces, like the two surfaces of a soap bubble or oil film.
What is quantum mechanics?
The field of study of atoms by themselves, as well as in molecules, liquids, and solids in which the wave nature is important, is called quantum mechanics. The atoms obey the Schrödinger equation. But for any atom more complicated than hydrogen, the equation can be solved only by a computer. Using computers to solve equations, run complicated models, and simulate experiments is an important subdivision of the study of physics called computational physics, which now has equal status with theoretical and experimental physics. Some of the recent accomplishments of quantum mechanics are in the areas of condensed matter physics, or the study of solids, and atomic physics. All of the integrated circuits used in MP3 players, televisions, cameras, and automobiles are designed using quantum mechanics. They are all based on diodes and transistors, where quantum mechanics describes and explains their properties and guides materials scientists to select appropriate materials for their construction. One of the most exciting new materials is graphene, a film of carbon where the atoms are in hexagon-shaped arrays, but the film is only one atom thick. Graphene is being investigated as a way of constructing extremely tiny transistors, and thus powerful integrated circuits. It may also be used as a sensor to detect single atoms or molecules of selected materials, or as a transparent conductor for touch-screen computer displays. Its discoverers won the 2010 Nobel Prize. From 1924 to 1925, Einstein and the Indian physicist Satyendranath Bose. 1894 to 1974, predicted that if an atomic gas were cooled enough, the atoms could form a new state of matter that would exhibit quantum effects on a macroscopic scale. The first experimental confirmation of this prediction occurred in 1995 when Eric Cornell, 1962, and Carl Wieman, 1952, at the University of Colorado cooled a gas of rubidium atoms to about 1/6 of a millionth of a Kelvin. They and Wolfgang Ketterle, 1957, at MIT shared the 2001 Nobel Prize for their work. While this new state of matter, called a Bose-Einstein condensate, has no existing applications, physicists are using it to improve their knowledge of how atoms interact at very low temperatures and to explore possible future applications to atomic clocks and computers.
What is a cone?
Cone-shaped nerve cells on the retina that can distinguish fine details in images. Located predominantly around the center of the retina called the fovea, responsible for color vision.
What is the lowest possible temperature?
The lowest possible temperature is called absolute zero, 0 K. It is the temperature at which molecular motion is at a minimum and cannot be further reduced. While absolute zero can never be reached, see the third law of thermodynamics later in this chapter. The present record low temperature is 4.5 Nk, 4.5 billionths of a Kelvin.
What is a light year?
A year is a unit of time, but a light year is a unit of distance. Specifically, it is the distance that light travels in 1 year. Since light travels at 299,792 km per second and a year consists of 31.557 x 106 s. A light year is 9.4605 x 1012 km or about 6 trillion miles. The light year is used to express distances to stars and galaxies.
On what does the gravitational field, like that of Earth, depend?
Newton demonstrated that the gravitational force on one object caused by another is proportional to the product of the masses of the two objects divided by the square of the distance between them. The gravitational field of an object would then be the force divided by the mass of the object on which the force is exerted. The symbol used for the gravitational field is g, and g is the so-called universal gravitational constant. It is called universal because it is the same for objects made of any material and of any mass from a 1 kilogram apple to a galaxy. The equation that describes the gravitational field at a specific location is G equals gm/r2, where m is the mass of the attracting object and r is the distance from the center of this mass to the location in space. The gravitational field is a vector quantity. Its direction is toward the center of the attracting object. Well, consider its magnitude shortly.
But who made it and where?
It is uncertain, but likely to have been made in one of the colonies of Corinth on the island of Sicily. Perhaps by a student of Archimedes decades after he was killed. One method of creating a pulley with a variable diameter is to use a V-shaped belt and a pulley with a groove that can be adjusted in width. This kind of transmission is often used with hybrid cars, and is being developed as a means of decreasing fuel use.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
Why do electricians work with one hand behind their back?
When working on high voltage circuitry, many electricians like to place one hand behind their back because this way there is little chance for each hand to touch objects of different electrical potentials and cause a shock.
What plays the role of mass in rotation?
Mass is defined as the net force on an object divided by its acceleration. By analogy, then, the property that takes the place of mass should be the torque divided by angular acceleration. The property is called rotational inertia or the moment of inertia. It depends not only on mass, but on how far the mass is from the axis of rotation. The further the mass is from the axis, the larger the moment of inertia. If you sit on a swiveling stool or chair while holding heavy weights, the further you extend your arms, the more difficult it is for someone to start you rotating. That is, it will require more torque to achieve the same angular acceleration.
Why do astronomers believe there is dark matter in the universe?
The first hints that there is more to the universe than visible stars and galaxies came in 1933 when the Swiss-American astronomer Fred Zwicky, 1898–1974, studied the motion of galaxies in the Coma cluster and estimated that in order to account for their rapid motion there must be 400 times as much mass as could be accounted for. In the 1970s the American astronomer Vera Rubin, 1938, studied the rotation of galaxies and found that at least half of the matter in galaxies must be invisible dark matter. Dark matter is also in evidence in gravitational lensing, where the gravitational interaction of mass with light causes the light from very distant galaxies to be bent by nearer galaxies. The result is a distortion of shape and position in the images of the distant galaxies as if they are being seen through a lens. In one set of colliding galaxies the center of mass, determined by the lensing effect, is separated from the center of optical and X-ray brightness, probably by the effect of the collisions. Radio and infrared emissions from the initial Big Bang that formed the universe is called the 3 Kelvin cosmic microwave background radiation. Understanding the details of this radiation also requires large amounts of dark matter.
What is an impulse?
The product of force and the time the force is applied.
What is the coefficient of kinetic friction Mk?
Coefficient when there is relative motion between the two surfaces. Smaller than static friction.
What can exert a force?
The first answer that might come to mind is that a person can exert a force. He or she can throw a ball, pull the string on a bow to shoot an arrow, push a chair across the floor, or pull a wagon up a hill. Many animals can do the same thing, so one might say that living organisms can exert forces.
How did the study of beta decay result in the discovery of a new particle?
In beta decay, a nucleus emits an electron. The electron isn't in the nucleus originally, but results from the change of a neutron into a proton. Studies of the energy of the emitted electron showed that, instead of having a single energy like an alpha has, the energies of the electrons were spread from near zero to a maximum energy. Early investigators recognized that this suggested that energy was not conserved in beta decay. Austrian physicist Wolfgang Pauli, 1900 to 1958. Proposed in 1930 that a second particle was emitted along with the electron. This particle had to be neutral and zero, or extremely small mass. And he named it the neutrino, or little neutral one. The neutrino wasn't detected experimentally until 1956. We now know that the neutrino emitted in beta decay is actually an antineutrino. The question of its mass will be discussed in the chapter on unanswered questions. When a nucleus undergoes beta decay, the number of protons increases by 1 as the number of neutrons decrease by 1. So, for example, carbon-14, 6 protons and 8 neutrons, becomes nitrogen-14, 7 protons and 7 neutrons. With the emission of the beta electron, and an antineutrino.
What are the effects of the Coriolis force on Earth?
A reference frame, or coordinate system fixed on Earth, is not an inertial frame. The Coriolis force affects the rotation of winds around high and low pressure areas in Earth's atmosphere. Air flows into a low pressure center. The Coriolis force in the northern hemisphere causes all flows to be deflected to the right, creating a counterclockwise flow around the center. In the southern hemisphere, the deflection and rotation are in the opposite direction. On the other hand, air flows away from a high-pressure center, and so the deflection causes a clockwise rotation in the northern hemisphere and the opposite in the southern.
What is a law?
Summary of many observations that describes phenomena.
How can you get circular motion?
If an object moves in a circle, either a planet, a satellite, or even a ball on a string twirled around, then there is no change in speed as it moves around the circle. So there can be no force in direction of motion. There must be a force, because the direction of the ball is changing, so its velocity is changing. The force must be perpendicular to the motion. Try to make a ball move in a circle. This works best with a ball the size of a soccer ball or basketball on a smooth, wood or tile, floor. Start the ball moving, then kick it gently in the direction perpendicular to its motion. Try another kick or two. Note that its direction changes. In the direction of the kick, the momentary force you placed on the ball. If you could exert a constant force that is always perpendicular to the motion, the ball would move in a circle. Note that the direction of the force is always toward the center of the circle. Such a force is called centripetal, or center-seeking. The force required to keep an object moving in a circle depends on three quantities: the mass of the object, the speed of the object, and radius of the circle. The force must be larger for larger mass, greater speed, and smaller radius of the circle.
What is a centripetal acceleration?
Acceleration due to a centripetal force toward the center of a circle.
What is a microwave oven?
Uses 2.4 GHz M waves to cook food.
What role does reverberation time play in acoustics?
Reverberation time plays a major role in the quality of sound heard in a concert hall. Acoustical engineers carefully design concert halls to achieve A typical reverberation time between 1 and 2 seconds. Rooms designed for speech should have reverberation times less than 1 second. Movie theaters a little over 1 second, and rooms designed for organ music have as much as 2 seconds. If the reverberation time for middle and high notes is too short, the sound will diminish almost instantaneously and the room will sound dry. A full bass tone requires a longer reverberation time for low notes. If the reverberation time is too long, however, as it is in many gymnasiums, the echoing effects will interfere with the new sounds, making music sound mushy and words of a speaker difficult to understand. Sound-absorbing foam panels with bumpy surfaces are commonly used in recording studios to reduce echo.
What is a lever?
Simple machine consisting of a rigid bar that pivots. 3 different classes.
Who really discovered oxygen?
Three scientists are often credited with the discovery of oxygen: Carl Wilhelm Scheele, Antoine Laurent de Lavoisier, and Joseph Priestley. The Swedish scientist Scheele discovered what he called fire air in 1772. The name came from the way an ember would burst into flame when immersed in the gas. Scheele wrote a book describing his work, but it took 4 years to be published. In the meantime, Priestley in 1774 discovered what he called dephlogisticated air. Lavoisier, who met Priestley in 1774 and was told about Priestley's discovery, claimed to have discovered what he called vital air. Although he was sent letters from both Scheele and Priestley describing their earlier work, he never acknowledged their receipt. Lavoisier's great contribution was to make precise studies of the role of oxygen in a variety of reactions and to give it the name oxygen.
What is a Fahrenheit scale?
Temperature scale on which the freezing point of water is 32 degrees Fahrenheit and the boiling point 212 degrees Fahrenheit.
What is a suspension bridge?
Bridge using cables from which wires are attached that suspend the roadbed.
What is harmonic?
Mode of vibration that is a whole number multiple of the fundamental mode. The first harmonic is the fundamental frequency. The second harmonic is twice its frequency, etc.
are series or parallel circuits used in our homes.
Each circuit, by itself, contains a series connection of a switch and lamp or appliance. The circuits themselves are connected in parallel so that they can be used independently.
What is nuclear physics?
Study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed.
What do AM and FM mean?
Traditional radio broadcasting uses analog, not digital, methods. AM, or amplitude modulation, and FM, or frequency modulation are methods of transmitting information on a radio. In each case a property of the carrier wave is changed, or modulated. These variations carry the transmitted information. AM was the first method invented and the simplest to transmit and receive. Edwin Howard Armstrong demonstrated transmission and reception of frequency modulation. In 1935, listeners were amazed the way that FM eliminated static because noise, like that due to thunderstorms, changes the amplitude, but not the frequency of signals. The FM receiver's output does not depend on the amplitude of the signal. Due to opposition from the radio networks and receiver manufacturers, commercial FM broadcasts were delayed and did not become widely available until after World War II. Radios once only had AM, amplitude modulated, frequencies available. Then came FM, frequency modulated, in 1939. Today, there is talk among radio professionals that AM stations might become a thing of the past.
How would lasers produce fusion?
The second method of producing fusion is called inertial confinement. Tiny glass, plastic, or metallic spheres containing about 10 mg of deuterium-tritium fuel mixture at high pressure are bombarded on all sides by extremely powerful lasers. The lasers vaporize the sphere, driving a strong inward shock wave that compresses the fuel enough to create fusion. The National Ignition Facility, located at Lawrence Livermore Laboratory in California, has been under construction since 1997. The design goal is to create a 2 megajoule flash of ultraviolet energy that hits the target from 192 separate beamlets. All of the beamlets must strike the target within a few picoseconds. In January 2010 the laser beams delivered 700 kilojoules to a test sphere, heating the gas inside to 3.3 million kelvins. It takes hours for the lasers to cool enough to deliver another pulse. The engineering goal is to deliver one pulse each 5 hours. Before deuterium-tritium fusion fuel can be used, neutron shields have to be built to protect the lasers. There are no accepted engineering plans to convert the energy released to electrical energy. One proposed method is to surround the bead with a blanket of liquefied lithium that would be further heated by the energy released.
What is a critical mass?
Minimal mass of enriched uranium or plutonium needed to create a bomb.
What are examples of levers?
The first class lever shown above has a mechanical advantage greater than 1.
What is an inertial confinement?
Method of producing nuclear fusion by using lasers to compress tiny amounts of a deuterium-tritium fuel mixture.
What is potential difference or voltage?
In a voltaic pile, today more commonly called a battery, chemical energy is converted into increased energy of electric charges. Positive charges at the positive terminal of the battery have a greater energy than those at the negative terminal. The quantity that is important is not the total energy difference of charges at the two terminals of the battery, but the energy difference divided by the charge. This quantity is called the electric potential difference, or more commonly, the voltage.
What did Newton add to the knowledge of sound media?
Although he mainly concentrated on classical mechanics and the principles of geometric optics, Isaac Newton, 1642 to 1727, did make several important discoveries in the field of sound. His major contribution was his work on sound wave propagation. He showed that the velocity of sound through any medium depended upon the characteristics of that particular medium. Specifically, Newton demonstrated that the elasticity and the density of the medium determined how fast a sound wave would travel. Because Newton worked before the field of thermal physics was developed, his theory has errors, but they are not significant to the calculation of sound speed.
How are conservation of momentum and conservation of energy used in everyday life?
These two laws are most often used when two objects collide. Momentum is conserved if there are no external forces, and it changes very little if the forces during the collision are much greater than the external forces. For example, if two cars collide, the two cars are the system. The forces between them are much larger than the forces on the wheels that come from outside the system, so momentum is conserved.
What is active noise cancellation?
Active noise cancellation, or ANC, creates a waveform that is the opposite of the noise so that the noise is cancelled. An ANC headset consists of a one or two microphones that detect the noise, electronic circuits that invert the waveform, and a headphone driver. Low-frequency noise is more successfully cancelled than noise at higher frequencies. So passive noise reduction is used to reduce high-frequency noise. As a result, low-frequency noises found in helicopter, jet engine, and muffler noise can be controlled. Using ANC while the high squealing sounds of jet engine noise are more difficult to cancel out. If anti-noise is produced by the headphones, can a person hear other people? Music, etc. sounds that aren't noise. The objective of active noise cancellation is to cancel out the noise waveform by producing anti-noise to interfere with the original noise pattern. Since the result is less noise, other sounds are easier to hear. ANC technology is now available for consumers in headsets that reduce noise and allows for easier communication in loud environments. As a result of this new technology, factory workers and helicopter pilots can communicate more easily, and their amount of stress due to noise pollution should be reduced. Airline passengers can listen to music through ANC headphones, while noise from the airplane is cancelled or reduced.
What is the first law of thermodynamics?
The first law of thermodynamics is a restatement of the conservation of energy. It says that the energy loss must equal the energy gain of a system. It relates the heat input and output, the work done on the system and the work the system does, and the change in internal energy, or temperature change. For example, the cylinder and moving piston of an automobile engine is heated by the burning of gasoline in the cylinder. The piston moves out, doing work, and heat is transferred to the coolant because of the higher temperature of the cylinder and piston. As long as the temperature of the cylinder and piston does not change, the heat input equals the work output plus the heat output. Energy isn't gained or lost, it just changes form. Another way to state the first law is that net heat input equals net work plus change in thermal energy. Note that heat can be either positive, heat input, or negative, heat output. Work can also be positive, work done by the system, or negative, work done on the system. Thermal energy can also go up or down.
What are ultra-high frequency, UHF, waves?
Frequency 300 MHz 3 GHz.